Okay, so we now start to talk about the basics of coding. And here's an interesting quote from the inventor of one of the most popular programming languages, C++. So there are only two types of languages, uh, the type that people use and those people complain about. So there's always going to be some of that complaint about why you have to do this. Like natural languages, sometimes you just have to remember the rules and follow them. So this is the outline of this week of discussion. We're going to talk about programming in some very generic uh, fashion, and then we're going to dive right into by looking into basics of operation, variables, assignment, and very quickly start to code some simple programs. And we're gonna talk about uh, the operating system just a little bit because I do want you to have some basic understanding of Unix and treat it as a programming environment rather than just an operating environment as a basic user. And after that, we will try to look into a bit more complexity of your basic programming by playing with functions. We'll define some functions to use, and then we'll actually invoke them. Okay, so we already started to play with Python a little bit to use it to do quick calculation. Here's a screenshot of what you have, what we had last time, but I'm going to bring up the programming window. And this is, by the way, the integrated environment. I'm not a big fan of that. I like my conventional terminals, but we'll go with this. So you get a prompt, the 3 greater than sign put together. That's a prompt for you to enter something. Okay, you can already say, okay, 3 plus 4, and that's an expression. And the interpreter, the shell, the Python shell, and we can see over here that this is Python version 3.1 is getting and executing for you. So you just did a piece of program, 3 plus 4, and the result is 7. Of course, you can do more, 3 raised to the 4th power. Most of the time, the programming languages do not care about these extra formatting things that we put in, like spaces. So that is exactly the same as this, which is exactly the same as that. Okay, all these empty spaces are ignored by most of the program. There is an exception to that, and we'll get to that when we get there. So if you do this, this is really just using, you can have compound expressions, of course, times 4 plus, I don't know, 45 multiplied by 6. You can do that. We don't have math just yet, but you can see that what I mean is we don't have a complex math function just yet, but just simple expressions, putting numbers and mathematical operations, simple defined operations. So it's an advanced calculator if you wish. You can do basic operations, and you can also custom, and we will see that. And if you want the result to be saved in your I guess, portable calculators, you might have some buttons that you do to store this into some result. In a programming shell, you can very easily just use any variable that you want to choose. A name, A, is now a variable, and you can say, well, let's make that 4 times 5. And from now on, A is going to be 20, and you can use it just as if it's the value that you stored, A times 34 is going to be 20 times 34. So right off the bat, you can already use Python with the interpreter interface to act as a calculator, an advanced calculator. But you can do more, obviously. So now let's think about what more you can do. Let's think about this notion of an app. You're probably, in this generation, you know what an app is. To you, that's this icon on your screen that you touch, which launches and allows you to do all kinds of things, to order a ride, order food, whatever. Okay, so an app is really just a short form of application, or an executable program. It's really a piece of code that someone wrote that has all kinds of functionality, that takes user input, that does certain thing and feedback to the user with a certain output. And it's usually very sophisticated to be very useful, so that they get used a lot and rank high in the App Store, and that you download or buy. Okay? So even though you think of them as this icon, this blue icon with some symbol in it, really that's just an association. The tapping of it is the launching of an application. Okay? This application program, I'm going to use them interchangeably, is a creative product, okay, that we're going to try to learn to write. At the end of this semester, you're not going to be a very fluent programmer just yet, but we will get you started on this. So we already saw a few programs. In fact, the very first line that we typed is, in the strict sense of the term, a program. It's just so simple that it's probably not very useful. So we want to do something more sophisticated. The thing about it is they look semi-understandable, especially if it's just a mathematical expression. It's okay, it's not too bad. Okay? But you have to understand, computers do not understand it at all. Okay? Not in the sense that you understand the symbol 3. It's appearing on the screen as this symbol over here, but deep down it's represented in some other way, and we'll get to that in due time. Okay, and in fact, we'll get into the larger part. The second part of the course is all about how this whole program that we just wrote eventually triggers whole bunch of microscopic element, gates, circuit, into producing the result that we want. Okay? So we'll get to that later. Right now, I do want to tell you there are roughly 2 ways of executing the program. One called interpretation, the other compilation. Not a big deal to know the difference, but it would help you a little bit. So the interpretation is what we just saw. It's on the fly. We type something and it immediately gets executed. Okay? And so this is useful usually to begin to code. In contrast to that, if you write a program in traditionally more compilation-based programming languages, you have to write the whole code. And then you have to go through a step to convert that code that you just wrote into machine understandable format before you can even run them. So they tend to involve more steps, and you are going to face that type of language, I believe next semester, depending on how you schedule your courses in AC 114. You'll be programming in C, and C is traditionally a compiled programming language. So let's start with a very simple program and use that as an example to show you how they differ in the way you program. Traditionally, when you learn a programming language, the very first program you write is called the hello world program, which is you print it out. Okay? So let's say I want a program that when I run does nothing but print out hello world onto the screen. Okay, with Python, you can type this program directly, and it involves a print statement. Let's use capital with that. Oh my goodness, this is Python 3. So that's one of the other thing about it. Sorry, I have to write it in that format. Okay. Those of you who know Python a little bit, programming languages evolve. Most often when they evolve, they have backward compatibility. Whatever they decided in the past is fine. They're not going to change it, but occasionally you make big decisions about what you have to keep, what you change, and print changed a little bit. So you need a parenthesis because now it's a function. In Python 2, version 2, it's not a function, it's a command. If this is confusing, don't worry too much about it. Now I have this program. So fine, I had the program, it has one statement, it says print. In the parentheses, I gave it what I wanted to print. And in this case, it's just a string, a collection of characters. I put them in quotation mark, good. Next time I want to execute it, what do? Can I tap an icon and have it run? That's the hope, right? So how do I put this into a program and save it? You can use any text editor to do that. That's usually my favorite. But in the environment over here, what you can do, I'm just going to reuse this. Copy and paste into this program. Okay, sorry about that. And now I have my editing screen. This is my editing screen. That's my interaction screen. Okay, this edit screen, I can put more to it, but right now let's just keep this. Okay, I can save this as a piece of code. Let's put it in. Let's put it in example and just call it hello. What's the benefit of something like that? We've done something like that before. See, now I have a piece of code that's in there and I can load. And back to my original screen, suppose I have this, what I can do is to open such a file. Oh God. Okay, so I reused it. Of course, for that one sentence that we typed, it's not much of a benefit, but from here on, I can execute this program multiple times. I am actually not very familiar with this. Ah, yes, okay. There you go. So you have to put your pointer into this window that you added. That's when the run button appears. So then you can run. As you can see, we started the program and hello world appeared, right? So let's try that again. We go back to run and it runs. So that's your program. And you can look at this piece of code. It's right there. And if you have a finder, let's say, to look at this piece of code, I believe we put it into code example right here. You can actually open it with something else. Let's say a text editor. Okay, doesn't allow me. Let me choose a different one, text edit. You see, that's the code that you just wrote. Okay, you can use any text editor to change it. For instance, if we decide to add something else. That's to statement, and we can save it. Okay, and you can see that file gets updated. Of course, we have to close the form, reload it, because what happens was we changed the file on the disk, not the one that we just opened. So we have to open that again. Now this program is slightly longer, and we can run that. Okay, if you remember it, that's F5, and you see we have a program that runs these two statements. Okay, so in an interpreted language, you can just type as you go. You can save the program. You can even type that. Sorry, you can even type that on the terminal itself. It's one of my favorite ways to input something really short. You can also use interpreter. Let me actually demonstrate that too. Nope. I want to bring up my terminal. Okay. So this is just terminal. We'll get to that, how this works. So we actually have the code right here. Okay, that's the Hello World program that we just typed. Okay, so we can use Python directly, and it will run. So these are two quick ways to run your code, but you can also, in that terminal, type Python, and you are now in, and you can do the things we said you can do. So this is terminal. It's one type of environment. Here we have the integrated environment, where you can type in the shell or load and save files from a file accessing window. Okay, so if you want to run C, on the other hand, you can't do that. You have to go through one more step. Now let's look at this just a little bit. Okay, I don't have it. Okay, never mind. I will just type it up. So suppose I want to write a C program. I can type it too. See if I can save some typing. No, that's okay. That's image. I'm gonna type it. Says include stdio h name print world exclamation mark. No, sorry. It's printf. I believe it's. What else am I forgetting? I think that's it. Oh yes, maybe we wanted to go to the next line. Let's do that. Okay, so we have this program. I can show you the thing that we just typed. We can't run it directly. We can't say, you know, like instead of like what we just did, Python, what was it, hello.py. We can't do that. If we do this on our new code, it will say, I don't understand this. Okay, so is there a version for C to do that? Unfortunately, no. What you had to do is to compile it. Let's use GCC to compile it. It goes like that. Ooh. Unable to find utility GCC. Okay, so I haven't installed this. Great. Let me switch a little bit. Type this. I will use a computer that I do have this installed. Bear with me just a second. Great. Okay, now there. Let's go to a random directory type. Okay. Oh, I have the. Oh, this is too long. I don't want to try that. Let's call it b.c. Loop. I already have that. x.c. Okay, now I have my program and I can compile it. Okay, everything went fine. And a new file just got created. I don't know if you can see this. It's right here. Okay, and this is the file that I can run. If I say a.out, you see what? That's the program that we just run. So what is this a.out? Can we look at it? Yes, you can. Ooh, but it's not very visible. It's not very understandable. It's a whole bunch of crap. If you pay special attention to it, there may be something that you can see, like, oh, there is some readable text over there. Okay, but by and large, it's a whole bunch of crazy characters. We'll get to that later on. You will understand why. But mainly, what we just created is. Now I've damaged the script by cutting it. Okay, this is terrible. But mainly what we just created. Let's go to a different screen. Where was it? Temp. Mainly what we just created is an a.out that is about 6,600, 700 characters long. Okay, 6.7 kilobyte. And this is machine code. This is something that the machine, the computer understands. And when I type this command, we're basically saying go to the current directory, load that thing, and execute it. Okay, in this Unix screen that we have, it's very manual, if you wish. It's very command line-ish, but it works. In a smartphone, all this is going to do is to attach an icon to it, that when you tap the icon, the same thing happens and it executes. Okay, so what's the difference? Really, you have to compile the code a little bit so that it becomes a executable and it stores in the executable format. But in an interpretation mechanism, this changing from human readable or semi-human readable code into machine recognizable code is done on the fly. So let me repeat this. Let's look at the code. We code statement A, B, C. These are high level. These are really texts. Okay, the machines don't understand them. We'll see what that means when we get to the point to discuss the construction of a computer. And what happens is we need to go through a process called compilation, and that's running some code. And these are machine recognizable code. The green things represent machine recognizable code. Okay, these circular things. And they interpret these higher level languages, sort of text, and convert them into machine code instructions. And we will see exactly what they are in the second half of the course. And now that we have this machine code, when we're running it, now we're just running this translated code, the product out of the compilation. Okay, this is why this is illustrating what we did with the command called GCC. Okay, we did GCC a dot or x.c. Rather, this is to say, please, the compiler is GNU C compiler. That's what this program is. It took the code that we just wrote, x.c, took the high level language, converted into something that is not very understandable to us. And from then on, we can start to run it. In the interpretation, this process is gone. It's not there. We didn't have to compile it. We simply run it. But the same process is still running. The interpretation is really, if you wish, a compiler on the fly. Every time you type something, this compiler, or Python in this case, the interpreter runs, tries to understand what you mean and generate the machine code right over here, perhaps a couple of instructions for every statement, sometimes more, sometimes less. And then once we're done with that statement, we go back to the compilation or the interpreter and generates more, and so on and so forth. So this is really the difference, okay? So that said, this compilation versus interpretation is not a language characteristic, it's an implementation decision, though most languages tend to have one type of implementation. We sometimes, in a short and imprecise way, say Python is an interpreted language. It's not technically true. The language itself doesn't define whether you have to interpret it or not. But the distinction is operational. So if you learn a language in Python, we don't have to do this next time you execute or try to program in C. You have to jump through hoops, and you ask why. This is why, because we're implementing it this way. Okay, and in the future, this distinction may even disappear. Right now, this interpretation on the fly can be so quick that you don't have to worry about it. So when we get it when we mature the compilation process, maybe you can ignore the difference. So back to the basic operations. We've done some multiplication, parentheses, add, all of this basic math that you know you can do. There are a couple of things different from your normal notation in, let's say, middle school. One of them is to represent numbers that has, that has an exponent component. So this means 3 times 10 raised to the 8th power. This means 1 times 10 raised to the minus 9th power. Double slash is not division, but divide and round down. It's an integer division. You can have modulo, left shift, so a couple of them. And you can read online about the operators' precedence. The first is lambda. If you don't know what it is now, doesn't really matter, on and on and on. Okay, so lower priority to higher priority. Okay, which is, there are some obvious ones, you know, multiplication and division are higher than plus and minus. But if you can't remember the precedence, I would suggest just use parentheses to explicitly dictate what you want to do. Okay, so if we have this, then normal mathematical operations are fine, but what about trigonometric functions, sine, exponent? You can do those. They are symbol-based or text-based, so you have to import a module called math. You don't have to worry about it too much, what it really means, just go with it. So let's say we're here, we can do import math, and now it works, and math has a function called sine, and we can do that already. So with that, you can really just make this into a very advanced, albeit not very familiar type of calculator. You can have variables. A variable have to be, the name of the variable can be anything that is alphanumeric, meaning you can have letters, numbers, and one special character, which is underscore. That helps because sometimes I may want a variable called xy to separate them. But I cannot do that. If I do that, that would be treated as two separate names because there's a space in between. Okay, space is used to separate different symbols. So if you want that, usually you can achieve the look of two names separated with a space by underscore. So underscore is a legitimate character. Okay, so variable names must be a letter. The starting character has to be a letter, cannot be a number. And that makes sense because if you name your variable x3, that's fine. You can say this is 5, that's fine. But you name your variable 3x, that's not fine because it can create confusion. Because 3e8, remember? That means 3 times 10 to the power 8. So numbers cannot start your variable name. So assignment is just equal. That's fairly easy. There are some shorthand things because x equal x plus 4, this type of thing happens so often that I believe this is introduced in C and Python just borrowed it. It happens so often that we want to use x plus equal 4 to mean increment by 4. So we've already dealt with operator precedence. Now let's talk about the programming environment. You already saw me using command line, and this command line is typically installed with Unix variants, Mac OS, Linux. We'll talk about that a little bit. There are a whole bunch of operating systems that are really very similar to one another. That's the beauty of the Unix variants. We can run directly, like what we did over here. Okay, never mind. We can just type Python hello.py. Which directory are we in? Oh, we were there. Okay, never mind. Oh, yes, here. Right, we can do that on the command line. We can also use the integrated development environment. The one that I will be using a little bit is IDLE. You can download them to your machine. Okay, so you can type anything here. The program would interpret it for you. And there are online environment. The textbook that we have, shown over here, has a whole bunch of don't know if I can click. I don't think I can click that. Nope, not even in this format. Okay. So I want to show you that. Let's move this over here. Go to the oh, what happened now? Okay, that I have to update that. The link was wrong. So when you're reading this online textbook, there are places where they will have a box like that. Okay, a box. You can run it in place, and it will show you this is what you typed. Here's what happens. You can drag this longer, wider. I guess you can change it. Right? And just run it here. So this is a third way of running. So there's at least these three very convenient ways of running your program. Use this. You can type whatever you want over here, right? For instance, you can go hello world. And run it, right? I believe they even save it for you So if you reload this page, the code that you just typed should stay in place. No, that wasn't true. Okay, never mind. I think there's an option to do that. The moment I can't recall how that's done. So, but anyways, you can execute these codes in these boxes. Any page in the whole process, in the whole textbook where they have a code box, you can do that. So that's running this code. There are all these different ways of running the code. Now let's turn to Unix and explain why I want you to use the Unix environment to do this, even though there are all these 3 different ways of coding. So if it's a little bit too overwhelming for you, pick one. Okay, pick one, maybe install idle on your laptop and just go with that. It's fine. This is good to know. It reinforces this notion that how programming works, really. It's describing our ideas in a very succinct and precise way so that the computer knows exactly what you want. And using Unix has that benefit, especially the command side of things, and it's very standard. So we're going to describe this, but if this is too much for you, you can skip it. It's not a requirement. It's not something that you absolutely have to know. And that's what we're going to do next.